So in this tutorial we are going to study about pointers, and pointers are one of the strongest features of C++ and the most vulnerable feature also. So before talking about pointers, or before writing the formal definition of a pointer, we are going to discuss about memory. So pointers work with memory addresses. So I'm going to draw a memory structure here. So when we are talking about memory, we are talking about RAM, that is the random access memory. And you might have seen that your PC has 4 gigabytes of memory or 2 gigabytes of memory. So we are going to discuss about the memory addresses. So let's suppose you have a memory. A memory is divided into blocks. So let's suppose this is your memory, and let's suppose your memory is 4 gigabytes. So this memory block represents further blocks, and each of these blocks is of 1 byte. So this block, you can see that this one is of 1 byte. So we are going to assume that this is of 1 byte, and similarly there are a lot of blocks in your memory. So this is basically memory structure. This is how your memory looks like. So we know that if a program wants to start its execution, it will have to load into this main memory, that is RAM. So I'm going to write an important point here, and this important point is that if a program wants to start its execution, it must be loaded in main memory. So if your program wants to execute, it should be present in the main memory, and the reason behind it is that your CPU access this memory directly, and the access is fast. So RAM gives a fast access to the CPU. So this memory blocks have some addresses just like house numbers, and these memory blocks are assigned some memory addresses. So let's suppose we would assume that this memory block has an address 1070. I'm taking any random value. So the next memory block will have the value 1071, and then 1072, and so on. So the reason why we are assigning these memory addresses to the memory blocks is because we are going to store the variables and our code in the memory, and the CPU will access those variables and the data inside these blocks using these memory addresses. So we know that if a program wants to start its execution, it must be loaded in the main memory. So let's suppose we take an example of a program which says int a equals 5. So when this line is compiled, the compiler will assign this variable a to the main memory. Let's suppose here a is assigned, and let's suppose the memory address of this block A is 1076. So this is a random value that I'm taking for example. These are not the specific values, so the compiler will randomly pick an empty block from the memory and it will place the variable at this place, and this value 5 is stored inside this block. So this block is 5. So integers mainly takes 4 bytes of memory. Depending on your machine and on your compiler, it may take 2 bytes. So if you want to store a variable, or specifically an integer variable, it will take 4 bytes. So it is going to take 4 blocks, and these blocks have some memory addresses. So if we want to access the memory address of this variable, we know that we can use the ampersand operator followed by the name of the variable. So this ampersand operator, we have seen that before. It represents a reference, and it returns, this ampersand operator is a unary operator, and it returns the reference or the memory address of the variable. So let me now come to the topic, which is pointers, and at this point I will define pointers. So pointers are the variables, and they are different from the simple variables because they store the memory address of another variable. So pointers are variables that stores the memory address of some other variable. So the reason why we have discussed about this memory structure and memory addresses is because pointers store these memory addresses. So now this is the whole concept behind the pointers, and now we will see how we can actually create a pointer and how we can use these pointers to access a variable's data like A. So in C++, a pointer is represented by using this symbol asterisk, or it is just a simple star, and this is a unary pointer, and it stores or you can say it points to some memory address. So if you want to create a pointer, let's now do the implementation of pointers. So let's suppose you want to create a pointer variable. So we will write it like this. Let's suppose the name of the pointer variable is A. So this pointer variable, this line means that A is a pointer variable, or you can just simply say that A is a pointer, which more specifically it is an integer pointer, and because the data type is int, so this means that the pointer variable a will point to some integer value. So let's suppose there is an integer int x equals to 4, and we know that when the compiler will compile this line int x equals 4, it will store the value 4 in some random block, and it will also store the memory address. So if we want to just know the memory address, we will use this ampersand operator. So since we know that pointers are variable that stores the memory address of other variable, and in our case the other variable is x and the pointer variable is a, so we are going to do an assignment. So a equals to the memory address of x. So let's now just draw a memory structure of these three lines. So in the first line, x is assigned the value 4. So let's suppose this is the memory block and this is the variable x, and let's suppose the memory address of this block is 2051. So the value of x is 4, so 4 will be stored in this block. And remember that this block is of 4 bytes because integers store 4 bytes. And if we are going to write this line, it will create a pointer variable a in some random block is assigned to this pointer variable a, and let's suppose the memory address is 3072. So this pointer variable is also an integer, and it is stored in this memory, and it is also assigned some memory address. So now let's move to the next line. Next line assigns the memory address of x because we are using this ampersand operator, and it will assign the memory address of x to a. So we know that the memory address of x is 2051, and it will assign this value in this block. So now a is a pointer variable that stores the memory address. So it is storing the memory address of another variable, which is x in our case. So this is just basically the concept behind the pointers. So the next step is we are going to print pointer a. So in this line, what I'm doing is this will output the value of x, which is 4. So this pointer now doing some other task. You can say that this pointer is now doing dereferencing. So this line pointer a will just point to the value of x, or you can say to the value at this memory address. So when you will write this line, you're actually printing out the data stored at the memory address of a, because memory address is 2051. So the pointer will go to the value at this memory address and it will print it out, and this is known as dereferencing. And the definition of dereferencing is that dereferencing just refers to the change, or you can say to changing state of a pointer. So simply what we are doing in this whole program is we are creating a pointer variable that stores the memory address, and if you want to access that value of the memory address, you will just use this pointer operator in front of the variable.